Hello and welcome back to I forgot what I called this. Creating a compiler in Scratch. From Scratch, not in Scratch. Oh my god, we're not writing in Scratch. Recreationally, right, Soding's word, recreational programming session. Welcome back. We're going to call this one episode 1. We last time set up some mechanisms for reading in files. The only thing we haven't done is do a little fread loop here, which I started to set up off camera because I didn't want to bother with making up a bunch of prototypes. But we're going to read in some file source text. We're going to validate that we got the source text properly read in, and then we can start reading some tokens in for C. So what I did off stream was just assert that I said I didn't want to implement. I'm just going to not implement it for now, and we'll add it very soon, probably, when I figure out what I want to call. We're probably just going to have it call, like, printf and exit, let's be honest. So when we get to the point where I need to start checking more stuff, we'll do that. Standard IO got a few more things here. We have our size t, null, EOF, seek stuff for file reading, and then I'm on Windows right now, so I went ahead and just put in the Windows declaration for standard in, out, and error, just in case we want to fprint anything. I'm going to try to avoid fprinting anything so that I don't have to make this portable. These headers need to be as platform agnostic as possible to avoid pain, basically. But I mean, here we've got stuff. Fopen through ftell here will give us everything we need for some really simple file reading. Let me do that. Beyond that, strcomp as well, because we used in the context here strcomp and never implemented it or gave it a header. So there we go. That's what we've changed, basically. A couple of header file changes, and I've uncommented our asserts now that we have the macro for it. So we need to go write a simple file reader. So we're just going to make a static, and we want it to be a const char, I think is what we said. Text is const char, and it should be null terminated. Const char pointer, read file, and we're just going to call it layec read file. Yeah, that's fine. So we want const char file name. My keyboard's in a weird spot. I don't know why. So we need to, let's go ahead and just assert that this file name is not equal to null pointer, or file name, right? We don't need to do that. So file stream equals fopen file name, and we want it just for reading. And then somewhere over here, fclose stream. So we need to include standard IO. So that's what we got here. Let's do a nice big old fseek. We want to get to the end of this stream, seek end. And then we want to long int, I think is what we ftell from. File length equals ftell stream. Do I not have ftell? What the hell? Standard IO has ftell stream. Oh, I do. It just looks funny. Oh, because it's a long. I was expecting long int, right? Long ftell stream, and then we can fseek. Oh, fseek needs more. That's right. I'm stupid. 0, and then fseek stream 0 seek set, like that. And then we can do some allocations here. So char pointer data equals, I need to turn off notifications, don't I? We need to, here I don't care about it being 0 initialized, so we'll just malloc. Ooh, why don't we have malloc? Oh, because we just haven't done malloc yet. That's in standard lib, right? We did calloc. We didn't do malloc, which just needs, I guess we do just want count, not size, and like that. Cool, so then we want malloc of file length, and that can just be an unsigned long. Well, it might just be a size t, which I have now, and we'll go check that later, but I don't know. So allocate file length +1 for a null termination. So then data sub file length gets null terminated, and fread into data the we'll do file length of 1 like that from stream, do the thing, F close, put a little to-do in here, file reading, error handling. This is an easy thing to add error handling to later. If it dies, we'll know, it'll be easy, it's fine. So then we can just return data, which is null terminated. So then all the way down here, let's just assert first that, what the heck, we're going to read this in and say that file source text is what we're going to call it, const car file source text equals Laye C read file name. Make sure that came back as correct, and file path. Now we got to do some consistent stuff here. Cool, cool, cool. So then context sources, whatever, that needs a this. Cool. Now we should be able to do stuff with files. Right, we want to add a source buffer for file. So let's go into our driver and start implementing something. We want to include layec context, which will also include other stuff, but will explicitly include source as well, because those are the two that we actually want, context and source. And I'll put context on top. So let's see here. We'll go ahead and make it so if argc is less than 2, we'll print usage. For right now, we'll have to write a parser for this stuff in the future, which we can do a fancy way if we want, or we can not. Then we want to just say, make it const car file path equals argv sub 1, not 0. Then we can do some things here. Let's make a layec context equals layec context create. Layec context getter add whatever. Context file path is going to have int source ID. Then we can assert for our purposes that source ID not equal to 0, or rather is greater than 0. We should also probably just throw in an assert that context is not equal to 0, and we can grab assert.h from there. Kind of going fast because I want to get to the Lexer, but so then all we have to do is source buffer equals layec context get source buffer from the context for the source ID, and then we can do one more assert source buffer dot. Let's assert that the name is the same, just so that we know that that worked properly and that we assigned it right. And then text does not equal to null pointer, basically. And then we can just print f. Actually, we're on Windows, so we could f print f, but it wouldn't work on WSL right now. So print f mod s probably doesn't even need. It's fine. We'll include it. Source buffer dot text. Cool. So then if we come over here and build, that is not how you type build. There's a warning. I want to catch warnings before I get to them. So context 29 up here. So that was fread file length needs size t, and this is not a size t, so size t. Build. Cool. Then I guess what we should also do is quickly assert that file length is greater or equal to 0, so that the cast is good. That makes some sense. Now that it's built, we can build, build, win32 is what I'm on right now. It's min-gw, but it's fine. Is that what I called it? Did I call it build win32? I did. Okay, so then we want layec, and this should give us the usage, which it does. And then it doesn't return yet, but that's fine. So then if we give it a file, like it doesn't matter, so let's just say source driver.c. There's the file contents of driver.c. Cool. So let's go ahead and add all that. So this is, I don't know how it is. We add file reading to add file reading works for me. Git push. Doot. Okay. Then go back into the driver here. Now that we've done this, let's next step here. Printing usage should just return 0. Now that we've got a file path, instead of asserting, we can say if source ID less equal to 0, we can return 1 and just printf, which should be fprintf to standard error, I know, but again, until I get that, I don't want to have cross-platform stuff at the moment, so we're just going to printf. We're going to printf unable to read source file. For now, let's call it this. It might have to, hold on. We'll just say if source ID is less equal to 0, return 1. And we'll do the errors in here. Right, so then what we can do here is let's try to get the file read first, and then if file source text is null, we're going to return 0 here as well. And then at this point we can assert that we did in fact return 0. So then here we can just print f that failed to read. I don't know, I like could not read file mod whatever file path. Then we don't have to handle that elsewhere. And then up here, if stream is null, then we can return null, basically, and then if, we'll do more error handling there, but at the very least, if it fails to open the file, that's the big one. So we can even test that by build and just say like driver C2 could not read file. Cool. But it should still do this. That is great. So can't type. Source files. I'm going to periodically clean my build just so I know everything is working properly. Then that's ready to go on lexing here. Let's always assume that it's a C file and just go build some Lexer stuff. We still have that token stuff we got to implement, but let's go ahead and also build the Lexer. If n def layec lexer c lexer h. Go ahead and define that. Cool. So type def struct layec lexer will be that. And I'll really quickly do layec lexer create and layec lexer destroy, just so I can scaffold that out. Token has our token data. Let's go ahead and make lib folder for Laye and a folder for C. In here we want a C Lexer, which can include layec lexer. Probably don't need anything for token until we get to like printing tokens, I guess. So let's go ahead and make a token.c include layec token c token.h. That will have things for like token to string or printing a token, I guess. So we don't need to to-string it all that often, we just need to print it. There will be a case eventually, maybe, where we want to to-string it, but at that point, we we already have this string value here for anything that needs to be complicated toStringy, or the source location. So toString is basically just a slice, a string span. And if we're returning stuff like that, we should probably have it wrapped eventually. So that may be a thing that happens here. If I go into, if I just go into, let me think about this, because we're going to want it for parsing anyway. If I do util.h, I'm a little all over the place, sorry. Laye util h define, and if we're not going to make like a huge dedicated string library right off the rip, probably, this might get turned into one eventually. But let's just type def a struct layec string view like that, which will have const char. I guess it doesn't have to have const char, it could just be char pointer string data memory. I like data, and then a long man. I'm gonna do that too much. I need to stop. What was I doing? Length. So then we can also just layec string view create, just in case we don't want to do fancy inline constructor stuff. Nice to have an API for it. Card data long length. This also gives us validation. So we can go to lib util.c, include layec util.h, and then here we just return a string view with data equals data, length equals length. And then assert anything I want to assert, actually. Length is greater than or equal to 0. So include assert.h. Then if length not equal to 0, then also assert data, I guess. Just do that. Cool. So now we've got access to a string view here. It's going to not own its memory, so we're not going to be destroying string views. This is just a helper function. So then this string value should probably turn into a string view. Maybe. It kind of makes sense that we own the string here for string value in some cases, but not others. So like if the string value is just going to be the identifier, we don't want that to be an owning string view. We just want it to be a slice probably into, well, I say that, but for C identifiers, there are like, I don't know, you can do like U something here, right? And this is part of the identifier. So then this, if I say like, I don't know, 68, 78, 68, then it becomes token H, right? And that's a valid C identifier still, but this is not part of the identifier. It's turned into an H. So this will probably still, in plenty of cases, turn into an owning string. I just really like it to not have to be, right? It's like 50-50 if we have to own it. Because for almost every single case of identifier and keyword, we just want the non-owning version of the string. So maybe we add a flag on whether or not we own the string. The tokens are going to live for a long time anyway, probably. We might just end up copying the locations over the tree and removing everything here, so they'll only live through lex, in which case, if we care about freeing everything, we do want to get rid of all the owned stuff. And I just want to know how we want to track ownership here. Do we create new strings here? I don't know. I think what we can do, hear me out, is we don't use string value for identifiers or keywords. We really don't need them for keywords once we know what keyword they are, but for identifiers, if string value is null or string length is 0, I guess, either or, then it can just call like get source image or something. So if I have layec string view, which I need to get from util singular, util.h, layec string view, layec c token, get source image for layec C token and token. What that'll end up doing here, this is the kind of thing we want to have in a token.c, is we need a context. That's something I forgot. layec context, which is going to come context. We need to be able to look up the layec source buffer, layec get source buffer for token dot location dot source ID. Boom. Let's also assert context while we're here, and also assert token location source ID. And then we can assert a solid source buffer dot text. And this needs to take in the context that we're getting it out of. So now we have access to the source buffer. We can just say return a layec string view create from the text. And since we're not owning this buffer, we probably should go ahead and make the string view const just to be nice. If we need modifiable stuff, I think we should own it, is probably the idea. And then we want the offset and length in here. So text plus token location dot offset, and then the length is token location length. Does that have any conversion errors that I should fix? Error and, okay, so assert needs include assert.h, and then yes, there was a conversion. Const car pointer to a type of car pointer, discards, qualifiers. Yeah, but I fixed that, didn't I? Oh, I did it in one spot, but not the other. Okay. Build. Perfect. Cool. Now we can get, I call image the picture of the word basically in the source text, what it looks like before lexing without any processing on it. So in the normal case, we just look it up and get a view on it. No problem. And then we can have a special case in here eventually where we use this, and then this should probably be a view. We should probably allocate this and say if it exists, then we want to intern it and deallocate the original, or alternatively, we just intern everything as soon as we get it, so we don't have a bunch and like a whole lot of stuff floating around. And this, yeah, this makes sense as a view then. So let's change that real quick. String view, string value. So what that brings up is we want to intern things. Sorry, I'm not streaming, so you can't tell me to slow down. Oh, I'm not documenting things. Token, return a view into the original source text at the location of this token. This is the literal text of the token as it appears in the source, not a processed version. Cool. Then we'll document token in a second. Lexer has a create and destroy we can get to in a second. Util has, oh boy, why does it do it sometimes? Create a string view from a pointer and a length. String views do not own their data, so we do not like them modifying it. Cool. Simple string wrapper, which does not own its data and does not need to be null terminated. A view does not own its data. It is simply a window into existing string data. Sure, something like that. So token has this. We decided that context needs an intern system as well. To intern strings, we're going to want another buffer here. So I think we're going to put off interning strings until we have another concept of a buffer here that we can put things into dynamically. So let's just get to lexing. There are a couple of functions we're going to need that I have pulled up on the side because I've written things like this before and I don't want to forget them. Some of these most of these are going to end up being static functions, and we only really want to return a, what I'm going to end up calling a layec token buffer. Right. And I don't need this Lexer here either. We don't need to Lexer create or Lexer destroy, so that's actually not useful at all. All we really care about is layec token buffer, layec c get tokens, and then we can take in a layec context pointer context and a file ID, a int source ID, like that, and it will give us all the tokens for that ID, basically. Boom. Return a buffer of tokens. Return a buffer of tokens. Then I don't know how to make words out of that. Sorry, brain's processing. Give me just a second. While I'm thinking, we want to include layec context, and that's it. Something like that. So then that's what we want to go implement in lexer.c. None of that other stuff. We do still want this. We just don't need it in the header. So layec context int source ID. Then we can go ahead and have a source buffer cached. We'll probably still want the source ID because we want to tag locations, but we may as well cache the source buffer. So layec c lexer doesn't need to be keep allocated. That's fine. So we'll just call it lexer equals some dotting. Context is context. Source ID equals source ID. Let's go ahead and assert that context is a thing and that source ID. I guess instead we could just say, hey, if source ID is a bad number, we give bad stuff, but include assert.h, and then we want to be able to return this buffer that doesn't exist. Lexer source buffer equals context get source buffer context source ID. And we can just go ahead and, if we got this far, we want to assert Lexer source buffer text. Okay, so then we want to have a layec token buffer. Tokens. And we want to be able to return tokens, like that. So now we can go back over here and define our token buffer. Which again, I want to have vectors for, or lists or something, but we don't yet. So I'm going to quickly scaffold this out, and the next time we have to write a vector, which will be soon, we'll go ahead and put that in util. So we want a layec token. So we need to include c token.h. And let's just do a pointer to tokens and a what? Long capacity and a long count. So this is where I'd like to just go ahead and get the vector out of the way because we're about to have to do it again. And I really like the way that the STB libraries do things. So I'm going to try to make a very simple version of STBTS in here, probably. And the way we're going to have to do that, I may have to pause here and think so I don't create boring and come back. If I can't, we'll make a really simple templated vector implementation. And by templated, I mean we're going to have to type def a bunch of things, but We'll see. Give me just a second. So I think I've come up with something pretty simple that again is kind of like the stbds library if you've seen it. Haven't tested this yet, we're about to test it. But we have a header that just has the capacity and count, and this is going to be in number of elements of whatever our vector is. We have a couple of utilities down here, one of which is an actual function, and 3 of which are pretty simple macro defines on a v vector and optionally this e element here for push. So what we're going to do is we're just going to treat any arbitrary pointer as if it were a vector of the underlying pointer type, the contained element type of the pointer. So like that is an empty vector of int. And what we need to do to manipulate this is we're going to say have this header prepended to any allocated memory. Whenever we maybe extend here, which includes allocating the base memory, we're going to allocate enough space for the capacity times the element size plus the size of the header, and then just whatever we return back to the user is the value after the header, and that's the memory they get to use. So our header is going to take just the capacity and count, do all the necessary mallocs and reallocs to get stuff going, and that's about all it has to do. The other macros in here, getting the vector count, just looks up the header through this macro, which is just, again, the previous element if it were a vector header. So v minus the size of vector header gives us the header. So we just get the length out of that pointer, or 0 if the thing hasn't been initialized yet, like if it's null, because we don't want to dereference a null pointer. And then the same thing for vector push, we just, hey, expand it if we can, by passing in a reference to it, the size of an element, which we can do by size of dereference the vector. And then we want at least one more as our required count. So we just get the count plus 1. Then we set the current thing we want to push, just normal index, e, v sub I equals e, and increment the count. This vector count plus plus should work, because this should be, well, it won't anymore. It did before I made this check. So now we need to increase the count manually by just saying vector get header of v count. And I've also typoed here, this is count, not length. And then let's make sure I didn't typo that in this file. There are no lengths in the vector. Okay. And for a little bit of readability, we're going to go back into our util and also define just vector as t star. So that now should give us simple vectors, I believe. So let's go test this out in our driver here. So we're just going to do a nice little return 1. Could return 0, but we don't care. We want it to error. Let's go. First, before I do anything else, actually, let's make sure that it builds. I didn't do that off camera. There are conversion warnings, so let's go take care of those. We have util 24. Down here, util 24, we want initial capacity times element size to be an unsigned long. Okay. Yep. Which is going to have to be the same thing in the realloc impl. Cool. Now we can go back into the driver and say return 1. And we can do what we did before with an int pointer, except we're going to call it vector of int. So we can grab util, and now we have vector int of test equals null, which we should have access to through standard IO. Beautiful. Then let's printf a couple of things here. We want to say vector count of test equals mod. Did I make it unsigned? It's just long. LLB. So then we want to return vector count of test. That's why I wrote it that way. vector count expects something. So there's a mismatched brace somewhere. This, oh, that's not supposed to be there, that's all. Cool. So then we can vector push test 10. You know what? 69, I mean. And then we can print vector count, and we can also print test sub 0. Vector test sub 0, like that. So if this works, we can try more complicated stuff. One more build here. It's going to give us warnings in main, I'm pretty sure. Incompatible pointer types passing int star star to type of void star star. Well, yeah. So let's just go fix that in the macro before we get more warnings. So here, void star star probably, just like that. Build. Cool. Now what? Vector push. Vector push is also broken? What do you mean? It doesn't say it's broken here. Is that just it being naughty? If I were to restart it, it'd be fine? Or so then let's grab that test 069. The count went up. So now let's go beyond the, I think I set it to 32 first. So let's do for int I equals 0, I is less than, I don't know, 100, I plus plus. We can then just vector push test I, which again, for some reason, does not like whatever's going on here. Yeah, there's just, it's not pulling the correct parentheses right there, but it exists in the header. So what if I close all of my buffers and reopen it? Now it likes it again. Beautiful. So then we can print test, which should be our print count of test, and we can print test of 69. For a more accurate reading. Well, we gotta build first. Beautiful. So now we've got very simple vectors we can add operations to later. So now we can do two things. We're going to first, I guess, three things. Git add dot git commit status. Let me just make sure. We have maybe a lot more things than I thought. We're gonna go with it. Git commit m let's see, add simple vector implementation, and we'll that's fine. So then the next step to do is in context, we have this whole thing that we basically copied earlier that we are now going to replace. So let's go into context.h over here, make sure that instead of sources here, we have a vector of sources, and we can include util like that. Cool. So then over here, we just want to create a source here by saying layec source buffer equals something, which we can do by just saying dot name equals file path and dot text equals file source text, which again we can just yoink the assert for. Then what we want to do is source ID would be int of vector count context sources. Like that. So then we just want to vector push context sources the source buffer. buffer and return the source ID like that. So then over here, we want to say everywhere that we use the sources count is vector count of source, whatever, like that. Then context.h is still complaining about util, I guess, but it should build. Yeah, close the buffer, reload the buffer, still not happy. But it's right there. Okay, cool, now it likes it again. So now that we've built, build, and run it with source driver again. Cool, no seg fault. We're not printing the text anymore, I don't think. Oh, we are. Oh. Well. Huh. Well, that's not good. We might have to go ahead and implement assert to make sure nothing's going wrong. We're going to implement assert as do something while 0, and then we want to say if not condition, then simply do a printf for now, assertion, assert failure, I don't know. And then we can concat condition. Rather, we can just do condition like that, I think. I don't actually remember how to stringify that properly. We'll see what happens. New line. And exit 1, like that. So then exit, where does exit come from? Is that standard lib? Standard lib exit. Standard lib like that. I believe it's void, no return, but what is the official signature of exit? Is it void? That's all I want to know. Void exit instead is cool. So there's absolutely nothing going on. I know it's no return, but I gotta make sure. So that should give us something, right? Call the undeclared library function exit with type void whatever. So assert should probably include standard lib.h so that we have a call to exit. Printf also needs to be like that. Okay, that still is not doing what we want. I'm going to go debug this for a second, and then I'll tell you what's wrong. Okay, so that was quick, I assume. I forgot to +1 this, and while I was at it, I went ahead and +1 here and threw an error to printf. So we just gotta now go back to our driver here and see if that fixes the problem, because it was silently just returning 1. So do a nice old, where is this build? And there's our source text again. Okay, so I'm going to leave the episode here. I know I said we were going to get to Lexers, but a little bit more grunt work than I thought going into it. Now we should be fully prepared to turn this into a buffer of tokens in the Lexer. So we'll do that next time. Thank you so much for watching. Don't hit the space bar. Yeah.